Okay, thanks everyone for coming. It's 10:30. So just to make sure we're all in the right room, this should be the room for CSE 545, Software Security for spring 2016. If you're in the wrong room, you need to leave. It's totally fine. We won't all look at you and laugh as you leave. It's totally cool. Okay, so today is kind of introduction to the course. I'm going to explain what this course is about, what kinds of things you can expect from the course, and what I expect from you in this course. So to start off with, I guess some of you, I see some familiar faces. This thing is going to really bother me. I'm going to see you. I have to walk around. Okay. So for those that don't know me, I am Adam Dupay. You can call me Dr. Dupay. You can call me Professor Dupay. You can also just call me Adam, which I prefer. So whatever makes you happy is fine. A little bit of background about myself. I did a 5-year 4+1 at UC Santa Barbara. So I did a bachelor's and master's there. After that, I went to go work full-time at Microsoft, where I was a full-time software developer up in the Seattle area, which is reminding me of the weather that we're having today, where it's like so cold I had to dig out sweaters to put on. And then, so I thought I would be like, I'm done with academia, I'm done with school, I'm finally gonna go develop software, it's gonna be awesome. And it was very awesome. But I realized that I was really missing doing research, specifically security research. So I left Microsoft after a year and went back to UC Santa Barbara to do a PhD there. So I did my PhD at UC Santa Barbara, and I've been here for about 3 semesters now. Let's see if I can do this without destroying my own computer. There we go. Awesome. So a little bit of background about myself and my research. My area of expertise is broadly computer security. You could call it system security. What my research focuses on and what I really love is finding vulnerabilities, and specifically using a computer program to find them, right? Because I'm only so good, but I'd rather have a computer program so I can run it on thousands of machines and find all those thousands of programs to find vulnerabilities there. So a lot of what my research entails is how can we automate the vulnerability finding process? How can we automatically find exploitable and bad security vulnerabilities before a bad guy is able to use them to compromise the security of your application? So any questions on me, my background, anything so far? I know it's a lot to take in the first 5 minutes. Okay. Course syllabus. Okay, so we're going to go over the syllabus because, like I said, this is going to be the contract between us, right? Okay, so what this course is going to be about, at a high level, what we want to study, and it should probably come from the name, is we want to study software security. We want to study how to build secure software. In order to do that, though, we've really got to understand how software breaks, right? So we're going to understand different vulnerability classes. We're going to understand how to find them, how to exploit them, and specifically, we want to really get an understanding of why do these vulnerabilities exist, right? This specific class of vulnerability, what's that core problem that causes it? And then how can we either through a development methodology, how can we ensure that we don't introduce this, or how can we try and find it, or how can we try and prevent it, or how can we mitigate it in some way? So those are really what we're going to be studying. So we'll talk about all kinds of actually really cool stuff. I'm pretty excited for this course. Sorry, this is a very large classroom. I'm trying to figure out where all this stuff goes. Questions on the overall course description? Anything you specifically want to see covered that's not maybe up there? I know there's a lot of people, but we're all friends here.
Yeah, maybe how some zero-day vulnerabilities like Stuxnet came to be.
Yeah, we'll study those a bit. Those are a little bit, I'd say it's almost a little bit more advanced in some way. So here we're going to study the very beginnings there, right? So we need to lay this foundation of what do we mean by vulnerabilities? What are these different classes? So now when you read about, oh, Stuxnet employed a zero-day buffer overflow vulnerability in so-and-so software, you actually know what that means, why it happened, and how they could have done that, right? Maybe I shouldn't phrase it like this, especially if it's being recorded. I want to give you the tools so that you can go out and find, so you can apply your security mindset that I'm going to teach you to a piece of software to be able to find those vulnerabilities before a bad guy does. And those are the things that Stuxnet and those other types of worms and everything use to be able to propagate. Any other questions? Okay, so prereqs. So this is a grad class. So if you're surprised by this, you signed up for the wrong class. So this course is going to be challenging. This is not a typical grad class. You just show up, do the minimal amount of work, and I give you a B, and we all go home. If you want that, please, there are plenty of other classes. I urge you, go find one of those classes, talk to your fellow classmates. I'm sure they'll be able to direct you to the right ones. This class is going to be challenging. It's going to seriously challenge your coding, your development skills, your thinking skills, and you may be exposed to, you may be learning technologies that you have no experience in. If this was an undergrad class, I'd have to teach you all that stuff. The beauty of a grad class is I can say, oh, here's a web application, it's written in PHP. Go find some vulnerabilities in it. And you're gonna have to learn some PHP to learn enough to go find those. Obviously, we'll cover some of the basic stuff, but the point is that you're really expected to learn whatever things, gaps, prerequisites that you are missing, that you need. You've got to, it's up to you to go find those and to go study those. It's one of my theories that being a very good, so part of software security, you need to secure software, but to secure that we need to know how it goes bad. So in understanding how it goes bad, you need to actually be a fairly strong developer yourself to understand what mistakes can a developer make. You kind of almost have to get yourself in that developer's mindset. And specifically in this course, a lot of the vulnerabilities classes that we're going to cover are binary-based vulnerabilities. So knowledge of C and C++ is going to be critical. And so this is why I say, yeah, it's a prereq in that I will expect you to know this, and we'll cover the things you need to know. But if you're in class and you feel like, oh, I don't really understand, why is the stack laid out like this, and why are these certain buffers in this put on the stack in this order, or if you don't know why we have a stack when we compile our code in C or C++, you have to go find that information out on your own. I mean, obviously we can help you if you come to us in office hours, but this is what I expect. So I'd say you need C, C++, be very familiar with it. The first project will get you familiar with it. And some kind of scripting language, be it Python, Ruby, PHP, I don't really care. And a solid background in operating systems. So why do we care about operating systems?
Because everything runs one.
Almost everything runs on an operating system, right? I mean, there is a trend now to try to compile applications such that they don't need operating systems, but for all intents and purposes nowadays, pretty much everything is going to run on some kind of operating system, right? And the operating system is a multi-user environment where you have different programs from different users all executing on the same thing, and so the operating system's got to enforce all these policies about who can access what, and so if you're able to understand how the operating system works, if you're able to understand why it's checking file system permissions, and we'll go into a little bit about how those permissions actually work and what they mean from a security perspective specifically, then this will really help you understand, okay, so what happens if there's a heap overflow in the kernel? Okay, what can a bad guy do? What kind of things can they exploit and do? Questions on prereqs? Now's the time to kind of get them out. You can ask questions about, I need to know this, I need to not know this, what should I be doing? Say for every question that gets asked, I'll make the class easier, but I won't do that. Okay. Recommended textbook. So this course does not have a textbook, so it's a grad course. We're kind of on the edge here, and really There are okay textbooks, but there's nothing that I feel is really great. And honestly, a lot of the material will be available online. So I'll give you, presenting material in class. I'll give you pointers to other reading material that'll supplement and will help. So that should be pretty much all you need. If you really, really want a textbook recommendation, email me and I'll be happy to provide one. Okay. Course communication. So I'll confess, I absolutely hate Blackboard. I cannot stand it every time I have to use that lovely piece of software. So we're not going to use it at all for this course because it's not necessary. So all of our communication for the class is going to be done on the class mailing list. So please go here, sign up for the class mailing list. It's a Google group. This allows me, all the class announcements will be made on this Google group. So, test anything I announce on the Google group, you got to know about. So you got to sign up for this mailing list. It's also a really great way for you to ask questions, right? Look around this room. How many of you are there? 130, something like that? Was it 140? I actually don't remember, but I think it's like 135. So got a ton of people in the class, right? There's one of me, we'll have 2 TAs, and but that's still 3 of us versus all of you. So the point of this is the class mailing list is an opportunity for you to ask questions and have your fellow students answer them, right? If you're struggling with, I don't understand why a buffer overflow works, or how do you do a buffer overflow if you can't, like where do you put the code, what do you do about readable, writable, stack, NX fits, all that stuff, right? If you ask that just to me, well, there's other emails, I have another class, so who knows when I'll get to answer your email. But if you put it on the message board, I can answer it, the TAs can answer it, and you all can answer it, right? Yeah, so I think it's proved very helpful in the past before, but I expect everyone here to be an adult and be grown-ups, right? So somebody says like, I don't know, I can't get programming project 1 working, like I can't, iterate reversely over an array, and you go, oh, here's the code you exactly need to do that, right? Then we're gonna have problems because you're interfering with your fellow students' learning, right? If you say, oh, there's a great resource over here that I used to iterate reversely over an array, perfect, awesome. They can go there and learn for themselves and do it. Or if you say, oh, the concept of reversing array is like I'm making this up, is like this other thing. So, if you think about it at a high level of this, and you're starting at the end and going backwards and in a for loop, at a high level that makes sense, and I think that's fair, right? You're helping them, you're teaching them. So take that responsibility on for yourself. It should be a lot of fun. Questions, course communication, mailing list, all that fun stuff. Okay, some of the topics, I don't think I'm going to cover it really. Yeah, it can change. I don't know, it's a great class. We can kind of do fun stuff. If there's something, like I said, if there's something you desperately want to see covered, let me know. I can think about including it or not, but free to ask, it doesn't hurt. All right, we're going to be covering all kinds of technologies. I didn't even list them all here, but this is just to help you know what you should be knowing. C, web stuff, networking stuff, that kind of stuff. Questions? I'm going to need a lot more interaction as we go on. It's fine here with the syllabus, but no. Focus here, yeah.
Will the gradebook also be in the Google group, or how will that work?
No, I can't. I think legally I can't do that because I can't see each other's grades. No, I will be. The grades should be very straightforward. Usually what I do in my class is I'll email everyone individually their grades whenever we have an update or something. For the projects, it's very simple because you'll know your score right away. So that's very easy. So yeah, and it's a pretty simple formula. So, all right. Homework assignments, so there'll be 3 or 4 homework assignments, and when I say homework assignments here, I really mean large programming assignments, or things that are going to help reinforce the things we talk about in class. You may be asked to write vulnerable code, you may be asked to analyze code for vulnerabilities, you may be asked to actually exploit those vulnerabilities, demonstrate that you know how to do that. that will be really what the homework assignments are for. And these are gonna be big, right? You're grad students. I can give you programming assignments that I would give as semester-long things to undergrads, right? And if that scares you, there's plenty of other classes, nice, great classes. Okay, we'll have a midterm. It'll be material we covered in class and the homework assignments. No notes, no outside material, completely closed book exams in my classes. Okay, projects. So the projects for the course, we're gonna get into, it'll kind of more be a second half thing. So we'll do the homework assignments kind of in the first half of class, and then the last half of class will be dedicated pretty much to projects. And the idea with the projects is you're gonna be creating a security library that defends against a common vulnerability class. So you'll get to choose from, we'll give you a list of X amount of security classes. You'll be able to choose, ooh, I want to implement a library that defends against cross-site scripting vulnerabilities. And it's up to you to actually write that library such that it does defend, does what you actually claim it does. We'll go into this in more details as we get closer. The TAs and I have to actually create the infrastructure to do this and define all the projects, and we want to be able to automatically validate these things, so we'll probably have defined interfaces for every type of vulnerability class, be it cross-site scripting, SQL injection, buffer overflows, heap overflows, format strings, any of the number of things that we're going to talk about in class. So you choose one, and you'll have to create a defense for it, right? So that's why it's an interesting project. The projects can either be done solo by yourself or in pairs. I really don't want to do group projects in this class. I want you to think about it on your own, or if you know somebody that you work well with, you can do that. But yeah, you'll be creating essentially a security layer on your own from scratch, which is pretty cool. Questions on the project?
Is there any language specification on which?
There will be, depending on the vulnerability class, right?
Sure.
So it doesn't make sense for buffer overflows to be written, I don't know, PHP or something like that. So yeah, that's part of the thing that when we get closer to it, we'll start defining, languages and vulnerability classes.
Sure.
So for the other assignments, for most projects, you can write them in whatever language you want. So we'll see that when the first homework assignment is listed. But there will be completely automated grading of all of the assignments. So yes, you can choose whatever language you want, but it has to run on our operating system, run against our test cases, and it has to have a certain interface, right? Otherwise we can't test everybody's. So this will be very clear as we get closer to the assignment phase. All right. Okay, there'll be a final. All right. Grading, so the homework projects will be about 50% of the grade, midterm exam 10, final exam 10, and so the project will be 30. Somebody calculate that to make sure it adds up to 100. Otherwise you guys are gonna have problems. Okay, so because the project is 30, this counts as the project portfolio of the master's stuff. So if you have any questions about that, feel free to email me. All right. So homework due dates and exam dates will be posted on the class website, and it'll be on the website and on the class discussion, and announced in class. So for every day, so let's say a project is due at midnight on a certain day. For every day that it's late, it's going to deduct 20% of whatever you would have gotten. So if you submit a 100% project a day late, it's going to be 80 points or 80%. Yeah, I don't know. I don't really want to do any makeup exams, but if you have, extenuating circumstances, please email me. I'll be reasonable. But I have to be fair to everyone else in the class, right? So that's the trick. Okay. All right. Now we get to a very serious part of the syllabus. So this is a very difficult programming intensive class. And it is a grad class, right? I still what I want you to get out of this class is I want you to struggle to try these things, to try to do things for yourself, right? And so part of that learning process comes in trying something and failing and trying something and failing, and then coming to office hours and talking to me, and then I can help guide you to the solution, and then all of a sudden that light bulb comes up and you go, aha, I know exactly how to exploit this vulnerability. This is amazing. I know how to write this really complicated piece of C code. And so by plagiarizing or cheating, right, you're reducing that and you're taking away from that. So I guess, well, there's a mouse there that's not connected to my computer that trips me out. Okay, so what would be some examples of plagiarism and cheating?
Submitting previously used code.
Submitting, well, previously used code. These will all be new, but yeah, submitting, if you find somebody else's code, right, online from this class, and submitting it, that would be a problem.
Submitting anyone's code on GitHub that relates to the project and submitting it.
Yeah, so submitting another student's code, right? So if it's after the deadline, we'll talk about that specifically in a second, but if it's after the deadline and you find some other student's code that they submitted on GitHub and you submit it as your own, right? That's plagiarism. What else?
Discussing groups for homework assignments when it's meant to be solo.
Yeah, working in groups for homework assignments, right? So the whole point, this is specific, so obviously it would be silly of me to restrict it so you can't ever talk with anybody about any of the assignments, right? I think that doesn't make sense. But you can keep the discussion at a high level. You can talk about concepts, you can talk about problems, but once it gets down to the code level where you're actively sharing code, or you submit something to me and I go, this matches 80% with another student's code, that's really weird. And you say, yeah, we worked on it really closely. Well, that's too close, I'm telling you right now. Think about how many possible ways could you write even a 300-line piece of code, right? An infinite number of ways, right, if you're doing it independently. So when it comes out the same like that, that's definitely when we have a problem. Obviously, this doesn't apply to the project with your group member, but yeah. So collaborating together, taking a prior student's code. What would be some other examples? Yeah.
Question. What about using code from like Stack Overflow?
So that kind of stuff, I think is totally fine. So if you use, but the important thing is, so just like the whole thing of plagiarism, right? If you're writing an essay and you go to Wikipedia and you take that paragraph and put it in your essay, what is that?
That's plagiarism.
That's plagiarism, right? You didn't write that. Those aren't your ideas. You're claiming those words as your own when they're not. But if you take a paragraph from Wikipedia, you put it in your paper, and you put it in quotes, and then you put --Wikipedia, is that plagiarism? No, because you're using somebody else's words, but you're attributing it to them. So nobody thinks, oh, Eric thought of those words, right? We know he got that from Wikipedia. So the same thing applies on the assignments, right? So if you use a snippet of code from Stack Overflow, absolutely fine. Just put in the comments right above it, hey, I got this from here. And also what this helps prevent is if there's a lot of people in this class, right? If you're both iterating, trying to figure out how to iterate over an array, you both take code from Stack Overflow. If there's no citations and we don't know where it came from, we just say, this bit of code is identical between the two of you. How could you possibly have not worked together? Right? So it also helps prevent these awkward situations. It helps you, all that kind of stuff. Any other questions I was asking before you asked that question? I don't know. Oh, what are some other examples? So we talked about basically taking someone else's code. We talked about working together collaboratively. What else?
Outsourcing.
Outsourcing? What do you mean by that?
Give it to someone else to do it.
Yeah, absolutely. We just send them. Probably cheaper ways to pass it. Yeah, that would be silly. Yeah, definitely. Don't do that. Take another class. Drop the class. Like, what else?
Literally cheating in the final exam.
Yeah, well, literally, yeah. I'll be here. That happens. We'll have serious problems. Yes. So it's no notes, no nothing on the exams. Yeah. So if you're caught violating that, that would be the same thing.
What if we find a security vulnerability in the testing
Yeah.
assessment?
We'll get to that in a bit. That's if you use that. So the short version is, if you use that and report it to me, I may offer you extra credit or something, because that's super awesome and it's really the point of the course. But if you use that to then harm, let's say, your other students, right, by like crashing the system, or you know are malicious and you are stealing the test cases from the system, right? Those are all super bad, very bad things. You're basically exploiting our submission infrastructure, which we're providing you to help and make grading fair, right? So yeah, definitely. But if you find something, let me know, right? Those are the kinds of things I want to know. So yeah. What about giving your code to somebody else?
In class.
In class, yeah. So let's say you gave Eric your code. Would you be liable?
Yeah,
Yeah.
obviously.
It's the same violation, right? So it works both ways. And the reason why I have to bring this up, I know I don't like talking about this. I hate that I have to take class time to do this. But as you can see here, I only taught so far 2 classes, and I've already had 20 violations of the academic integrity policy. And a significant amount of these were grad students too. So, and I treat grad students just the same as undergrads, everything. So if you're caught violating this policy, you get a 0 on the assignment, and we're going to report the violation to the dean's office. So what happens when it gets reported to the dean's office? Amy, now, didn't you sign something when you came here about like academic integrity and what happens? Yeah.
You know, one of the things is that you lose the ability to ever be a TA, RA, or work for the school in any way.
I don't know how long it is, but yeah, there's definitely for a period of time. I think you can't be a TA. You get put on a list. The dean's office keeps a list, which is not public and nobody can access. But if it happens again, then you're expelled from the university for a semester, or suspended for a semester. For master's students particularly, you basically can't do a CPT, so your internships, get compromised. And these are harsh penalties, but they're not my penalties, right? They're the department's penalties. And I'm making you all aware of it, and I have fully prosecuted every single case that I had. So I don't want to do it, but to be fair to all the rest of the students who are trying really hard and maybe aren't getting an A, maybe they get a B, or maybe they got 50% on the assignment, but they tried really hard, but they didn't ask a student for another code. Like, I have to be fair to everyone else in the class. So that's why I really don't want this number to increase at all, right? So let's just keep it at 20. Don't ever want to go up. And now that we've had this discussion, I'm sure it's definitely not. All right. So here's some examples, sharing code. So for this class, maybe you have to talk. So posting your projects online. Let's say projects, homework assignments is really what this means. So why do you want to do that? None of you's ever posted a homework assignment you've done online?
To show it to employers?
Yeah, to show it to employers, right? I totally get that. I totally understand that. The problem is, so how many other people have done that programming assignment?
150.
135 in this
Yeah,
case.
135 in this case. In some of your other classes, it could be literally thousands of people over the years. So from an employer's perspective, I already know you took the class and I know you got a grade on that, right? Because you sent me your CV, I know your GPA or whatever. So seeing code that you did in class for an in-class assignment,
Doesn't make sense.
everybody does it, right? It's like the bare minimum that you're doing to even pass, right? What employers want to see is you doing something extra, something different, something that nobody's ever done before, or not even sorry, that's a little too much.
Yeah.
No, it doesn't need to be that. Just something outside of schoolwork, right? Outside of the norm. Build a stupid little testing script. It can be little tiny things. I once wrote, well, this is actually my PhD, so I wrote a silly little Python application to tell me if I could have coffee or not, because I was trying not to get addicted. So it would like randomly decide if I could or could not, and then it would keep track so it wouldn't do it too many times in a row. I clearly, well, you'll notice, I clearly did not follow that anymore. You know, any little thing like that. If there's a script that you write for this class to help you find vulnerabilities, to help you do something, right? Those are the things that they want to see online, that you're going above and beyond. So really, it doesn't help you by posting the assignments online, and it doesn't help the future students, right? Because future students are going to take this class. It's happened in my other classes where they found a prior student's work. We obviously checked for that, and you know, there's a big problem. So yeah, so you know, you worked really hard on these assignments, so why make it easier for everyone else that comes after you, right? Make them struggle and learn. Any questions on that? So I think I'm going to change this. It'll be assignments. I think the projects, if you want to post online, because those will be kind of you, new, and unique, I think that would be cool. So I think that will be something that would be interesting to people. Any questions? All right. Okay. Yeah, the syllabus, we can update it. You know, it'll be updated at any point in time. All right. Questions? Course, content, anything? Everything's crystal clear. Exceedingly clear. House is really hot.
Would you want us to do a project report or something like that? Say no, say no.
It's a tricky question. I honestly haven't decided. I was going to decide as we got closer to the projects. Honestly, I don't think so. I mean, the only people it really helps, I think, are the master's students who have to write project reports anyways. I don't know. Do you guys want to write reports on your projects?
No.
I mean, we could write documentation, but that's it.
Okay, close your eyes and raise your hand if you want project reports. You can email me later. It's not great. It's a bit of a mob situation. Yeah, I mean, you know, this is a grad class, so I'm open to suggestions, feedback, that kind of stuff. For the projects, I mean, really, I just want you to do something really cool, like build some kind of really cool defense for your project. I'd much rather have you focus your time on that and making what you're doing awesome and having low false positives and providing a real tangible security benefit rather than, I don't know, spending time writing up how your project actually works. We could maybe do in-class, well, no, we can't do that. There's way too many of you. Yeah, I don't know. We'll see. Probably not. We'll say that for now. Anything else? Other questions? Class? Oh, I didn't write it on here. So I'm, maybe you saw me playing with QuickTime. I'm going to try to record all the lectures and post them on YouTube. But that's not a guarantee. So you're still responsible for everything that we cover in class. So if like I forget this little microphone thingy here, or if, I don't know, I forget my laptop or the file gets destroyed before I can upload it to YouTube, I don't know. You guys know, you've dealt with computers, right? Any of a number, Murphy's Law, anything could happen, right? So I'm not guaranteeing that they'll be on there, but I'll do my best to try to put them on there. So I think I've heard in other classes that it was very useful when it came time to midterm review and that kind of stuff. So I'll be posting on the course website, I'll post the slides, I'll post the links to the recorded lectures, and I'll post the any additional reading or anything like that. So, cool. Any other questions?
Is there an attendance compulsion for the class? No? Okay.
No, I don't know. You guys are paying for this, right? Yeah, so come, don't come, I don't care. Yeah.
Do you need to bring your laptops to the class?
You need to bring your laptops to the class. I think no, but I will try whenever there's like whenever I'm going through some kind of example or something that I've actually done on my computer or something like that, I'll try to include maybe the commands on the bottom so you can like follow along on your own. Or you can decide to do that later, however you want to do it. But no, it's too too many people to mandate that, and we don't.
Right.
Unfortunately, we don't have like laptops built into the desks yet. That would be kind of cool. Anything else? This side of the room? You've been remarkably quiet. Cool. All right, now let's get into some meat. All right, so.
Will there be any surprise?
Oh, we're done. I'm just kidding.
Okay, any surprise quizzes or anything
No.
other than that?
This is a great class. The programming assignments will be difficult enough. So it's recording. Go here. Let's see, I want a slideshow. How do I not? I think it's when it sets up the presenter view when it messes up. It's gonna mess up. But it's fine.
I think that's better, yeah.
You saw me hit the button to turn this. Yeah. I have no idea. Okay. So what is software security? What do you think?
Making software run as it should.
Making software run as it should.
That's good. I think that's good software.
Yeah.
Making sure someone else cannot do something other than intended with it.
Yeah.
Making sure someone else can do something other than what's intended. It's pretty good. What about an application that allows plugins? Would the plugins be allowing somebody to do something that they shouldn't be allowed to do or intended?
They shouldn't be allowed to split it with other plugins or something like that.
I mean, allowing expected use cases. I mean, like the use cases that the software was designed for. Only allowing those.
Allowing the use cases that the software was designed for? What else? Yeah. Wait a second. Yeah. Sorry, there's a lot of people. So. Yeah, let's come back.
Yes, security, looking security breach, such as like software.
As opposed to what?
Suppose maybe hardware or theory, randomized.
As opposed to hardware or theory?
Or
Oh,
no, it
physical
can be
security.
hardware
Mm-hmm.
or it can be just math. Doing mathematics together.
What did you say?
Make sure the information is secure.
Making sure the information is secure? It goes with, yeah, so the software that's touching a specific piece of information. The user's information, so making sure that the user's information is secure. What else?
Software, which doesn't have any vulnerabilities, which people can, use to extract information or something.
So software that's, let's say, vulnerability free. Yeah.
Maybe a process to prevent the exploitation of an application or software or hardware or anything like that.
So a process to
Malicious.
prevent, so like something you like plug on after the fact kind of, or maybe like I don't know, think of a castle like a moat. Like the moat's not really part of the castle, but it's a physical security measure to restrict who can access the castle.
A software that doesn't open gate for destroying the underlying architecture, whether it's a software or hardware.
A software, so say that again?
A software that doesn't open the gate for like destroying the underlying architectures.
Right.
Whether it's a software or the hardware.
Right, so the software, software that doesn't, maybe let's say, kind of goes back to intended use, right? Correctly allows people who should be able to access, and people who shouldn't be able to access, they should not be able to access. So what's security? What do we mean when we talk about security?
The correct authorization.
Correct authorization? What does that mean?
Allowing access only when it's allowed in the particular setting.
Allowing access only when it's allowed. Yeah. Yeah, I guess that's true. Well, it's kind of like part of the definition of access, right? I mean, a little bit. Okay. Yeah, that's part of it. Yeah. Yeah.
Protection.
Oh, sorry, just a second.
Security is try to achieve your goals, the security goals.
Whose security goals?
Usually there are
My
some
security goals?
universal security goals
I'd say that's probably true. It wasn't, not really the sense of security we're going, although, I'd say we actually use the word assurance more often to talk about that, right? So we want to be assured how certain or how much assurance do we have that something is secure. That's a good point. It is a feeling. Yeah, no, it's true because, I don't know, if we could know 100% if something was secure or not, I wouldn't be here teaching you how to do this, right? Because we could just know, right? So part of it actually is a feeling. Like, if you were to say, hey, I wrote 1 million lines of C code in this network application, I'm going to go, great, there's probably a ton of vulnerabilities in there. If you're like, hey, I have this 100-line Java application, a lot less chances, I don't have the feeling that that's less vulnerable. It could be just as vulnerable, right? I don't really know, but it's my kind of feeling, intuition. What else? What's that?
Protection.
Protection in what sense? From what?
Like not being able to access what.
Right, so back to access, right? So you're protecting, what are you protecting though? The system?
Probably the code or probably
The memory.
So protecting the code, protecting the data maybe, right? What else? Anything else? Okay.
Protecting society.
Protecting society, ooh, it's getting a little high level. There's probably aspects of that in there. I guess one of them, yeah. Talk about privacy maybe, right? So that could be protecting people from an oppressive government or something like that.
Or theft.
And theft, yeah.
Any kind of law that you could break. You can break a lot of them now online as well. So
That is
kind of
true.
merge that a little bit.
Yeah, that's interesting, society. Okay. So, I don't know, so there's 3 main things we always talk about in security, and so we've hit on a couple points, right, about how security people kind of formally think about security as, it has 3 goals. So confidentiality, so what does this mean?
Privacy.
What was it?
Privacy.
Privacy in what sense?
Of not
A third party cannot.
Of not disclosing data? Yeah, so you can think of confidentiality as only the people I want to read my data can read my data, right? So if I don't want anybody to read my data, I should have some way to do that. So that's part of the security of the system is what kind of confidentiality claims or what does it want? So from the perspective of a business, right, they might want to keep their customer list confidential, or going back to Eric's point, they may want to keep their social security numbers of their customers confidential, or the credit cards of their customers confidential. So then I think somebody over here brought up integrity. So what does integrity mean? Does that mean like doing the right thing and not cheating on your programming assignments?
Not allowing data
Data.
to be modified.
Yeah, so not allowing data, so we're talking here more specifically kind of about integrity of the data, or maybe you could broadly say the system. So we don't want, once again, somebody that we don't know or somebody that we don't allow to change
What data is
the data, right?
Or you can see the behavior of the system.
The behavior of the system is the integrity? I'd say that. I'd say that at a high level. Okay. What about availability?
Yes, it is.
Should be available. The data should be available.
Legitimate
anytime.
users should be.
Yeah, so legitimate users need to be able to access the system. So is this as important as the other 2?
Yes.
Yes, no, why?
Yes.
Yes, we do, yes.
That is the basic functionality, right?
It's the basic functionality. So without availability, you might as well have a system.
Doesn't that affect the other 2?
Does it affect the other 2 in what sense?
It's like, well, once you have availability gone, then the other 2 are just, it affects the other.
Well, if you can't access the system, how can you violate the integrity or
No,
disclose
like
confidentiality?
when someone who's not an authorized user is able to, it destroys the other 2.
What do you mean destroys? So can you?
like you can't have integrity or confidentiality when someone who's unauthorized is
Has
able to
access to the
access
data.
data that they shouldn't. I mean, if your system isn't up, then the question of confidentiality and integrity doesn't come into play anyway. So.
If your system is down, then the question of confidentiality and integrity doesn't come into play. Do you guys agree with that?
No, I don't.
You just said
No,
that.
I don't.
Have somebody else refute you and not yourself.
Availability is more linked to the performance of the system. So, if the system has some mechanism to detect whether there's some event like a denial of service, then it should have some kind of a fail-safe mechanism to drop down without compromising the other pillars. Like
Let's say it isn't, right? Let's say I can completely take down your system. What does that have to do? How does that affect the confidentiality and integrity?
you taking down the system should not affect that some other party that's dependent on the performance of the system does not gain access. For instance, if somebody, suppose I'm a bank and transfer to an account within my bank system is dependent on the performance of the system itself, then
Right.
the bank should come to a basic mode, that is the bank should come down such that no transfer should occur at time when there is a denial of service.
Right. So that's so kind of. I mean, in one sense, right. I would say that the confidentiality and integrity kind of have to do with the data that the system manipulates, right? So even if you can't access the system,
Maybe there's a way to actually.
I mean, as long as somebody can't access the data, right? I mean, if you assume so think about, I don't know, my laptop. Let's say I have a Bitcoin wallet. Laptop's a bad example. Say I have a desktop machine with a Bitcoin wallet of like $100,000 worth of Bitcoins, right? If I unplug that machine from the internet, right, take out the Ethernet cord, is that system available? Not really.
Right. Mm-hmm.
But I'd say the integrity is pretty good. It's at least certain that an external attacker is not going to be able to do it, right? Somebody has to physically break in and get physical access to my machine, which is still possible, right?
Yeah.
But the integrity and the confidentiality, in my mind, are kind of separate things, right? Or like if my data is encrypted, so it's confidential, that only I can see it. Well, now then, I don't care if you tear down my system and steal all my files, right? You still shouldn't be able to access any of that data. So it's still maintaining that confidentiality requirement, even though it's completely unavailable. Okay. It's almost time to go. These classes are so short. Okay, so we'll pick back up here on Wednesday.